Hello and welcome everyone to today's David and Beyond session on networking services and Oracle Cloud Infrastructure. Thank you for joining us. My name is Renu Bhatt, Program Lead for the Customer Enablement team here at Oracle. So in today's session, we'll dive into the core networking services of OCI and help you understand when and why to use these services, in addition to walking you through some networking design concepts. Today's webinar is presented by Vinny Yang, Senior Cloud Engineer, and Sunil Jan, also a Cloud Engineer here at Oracle. Joining us as an expert is Lynn Lois, Senior Cloud Engineer. Without further ado, I'll hand it over to Vinny.
Thanks, Renu. So as she mentioned, today we'll be going over networking fundamentals in OCI. So on today's agenda, as you can see here, we'll be going over quite a few different networking components in the cloud. So virtual cloud networks, gateways, peering, VPN security, load balancer, as well as fast connect. So today's session is really giving you the fundamentals of the networking service, how to get that set up. So it's really important, especially if you're, the networking person in your company, and also some extension of that. So also teaching you, how to keep your networking secure and keep your traffic where you want it to be. So here's a look at our complete cloud services diagram. And as I mentioned, we're focusing on networking, but just wanted to point out that will be under the core infrastructure section at the bottom here, under networking. So alongside all of these other core infrastructure services. All right, so before we dive into the networking components, I wanted to kind of talk about some of the behind the scenes that helps make our networking services work. So the first one I want to talk about is the physical network within OCI. So the physical network we have is going to be non-oversubscribed, so you won't have to deal with any noisy neighbors. So I wanted to ask you, Sunil, what exactly does non-oversubscription mean?
So what a non-oversubscribed network is in some network models, when you have your different OCPUs for your network, what's going to happen is that you will have the OCPUs that are currently in use, but other OCPUs that you're not currently using, but you have reserved, are part of a overall pool. On OCI, that is not the case. When you have your network and your OCPUs, they are not part of any shared pool. And no matter what the circumstance, once you have reserved those, they are yours. And hence it is a non-oversubscribed network because you have ownership of everything in your subscription.
Exactly. Thank you so much, Sunil. So really taking advantage of our non-oversubscribed network is really great for you because as a result, the physical network does operate at a very high scale, approximately 1 million network ports in each availability domain. So next, I want to talk about the virtual network. So within our virtual network in OCI, there is something called off-box network virtualization. And this tool allows us to put all the virtualization out to the network. And as a result, this gives us nearly zero performance overhead. And it actually enables the next layer up, which is all of the cloud services and cloud technologies offered to you, so that we can take any physical form factor and plug that into our virtual network, and allows you to use all of these services side by side. So next up, I just wanted to bring to our attention, how is security built into your environment? If you were here on some previous sessions that we've hosted, we talked about identity and how that's really the building blocks of keeping your resources secure. But as you confirm, those things, then you can continue to build on that within different services. So today we are focusing on networking and how you can keep, these aspects secure using the different tools within networking. Alrighty, so now that we're getting into things, again, we are going over these couple things: VCN, Fast Connect, load balancing, service gateways, and other gateways, as well as DNS. So the first tool that we'll be going over today is virtual cloud networks, or VCNs. And VCNs in OCI are software-defined networks that you set up in the OCI data centers in a particular region that you've chosen. So I just said that, these VCNs reside in a single region, but they can actually cross multiple availability domains, so they don't have to just, remain in one. You can still experience that high availability. And then within a VCN, you also have subdivisions, and we call this subnets. So each VCN is going to have many different components that will actually affect the direct behavior of the network. So things like route tables, security lists, things we'll go over in a couple slides. But basically, when you create one of these components, you're establishing a relationship between that specific component and the VCN itself. So you will have to have access to be able to both create the component and also manage the VCN itself within a IAM policy. But if you want the ability to update that component, so inside a route table, maybe you want to change the route rule, alter the security list rule, etc. This actually does not require permission to manage the VCN itself. So what I'm trying to say is, even though changing that component can ultimately directly affect the behavior of the network, you won't need that kind of overarching access to manage the VCN itself. So this discrepancy is designed to give you flexibility in granting least privilege to your users and not require you to grant that excessive access to the VCN, just so the user can manage other components of the network. That being said, just be aware that, by giving someone the ability to update a particular type of networking component, when you're doing that, you're basically trusting them with controlling the network's behavior. All right, so next up, we will talk about VCN address space and what that entails, as well as our different types of subnets. So within a VCN, it can cover one or more IPv4 CIDR blocks of your choice, and the sizes that are allowed for your VCN range from /16 to /30. So in the networking service, it will reserve the first two IP addresses and then the last one in each subnet CIDR. So for IPv6, you can actually enable them for your VCNs when you're creating your VCNs, or you can enable IPv6 on existing IPv4 only VCNs. And so next up, we have subnets. So we talked about how VCNs are regional. So Sunil, I want to ask you now, are subnets going to be availability domain specific, or are they also regional?
So subnets are both able to be placed at an availability domain level, a multi-AD level, or a regional level. They're flexible constructs. So depending on your workload, you might have a reason to want a subnet only covering a single availability domain or covering multiple availability domains. So they're flexible depending on your use case.
Exactly. Thank you, Sunil. I also want to add to that. So even though, you have two different choices for subnets, you can also kind of mix and match and have both availability domain specific and regional subnets within a single VCN. And we'll also take a look at that in the console as well during our demo. Moving on to, what types of subnets we have. So public. So private subnets contain instances with private IP addresses assigned to VNICs. And then we also have public subnets that will contain both private and public IP addresses that will be assigned to your VNICs. So on this diagram here, we have our VCN on the outer side, and then we have our two subnets inside it as subdivisions of the VCN. So next up, I want to talk about route tables. So these are super important. Your VCN will use route tables to send traffic out of the VCN. So it could be to the internet, to your on-premises network, or even to a different VCN. And these route tables will have rules that look and act like traditional networking route rules that you might be familiar with already. And so each route rule will specify a destination CIDR block and also the target for any traffic that ends up matching that CIDR. So the primary routing scenario is for sending subnets traffic to destinations outside the VCN. And a subnet has a single route table of your choice that will be associated with it. And all VNICs within that subnet are subject to the rules in the route table. So we have a screenshot here of what an actual route table looks like and two route rules that have been created inside it. But let's take a look at the bottom one here. So the bottom one has a destination of OCI object storage. So that's the end destination. But in order to get there, it does have to pass through something called a service gateway. So that is the target. And you'll have the target type, which indicates, what it's trying to route to. And then the actual target itself, which is a service gateway that exists in your environment. So this is an example of what it looks like to set up a route rule. But if you do have traffic, just traveling within the VCN subnets, that will actually automatically be handled by the VCN local routing, and you don't actually need route rules to be created in order to enable that traffic. And in the case that there is no route rule that matches the network traffic you intended to route outside the VCN, the traffic will be dropped. So next up, I want to talk about the different ways you can communicate to different destinations. So we kind of just went over one in that little example there, talking to an OCI public service such as object storage, but there are also different other destinations that you can use and get to within OCI. So the first type we'll talk about is communication to the internet. There's two ways that you can talk to the internet. The first way is to use an internet gateway, and this gateway will provide a path for network traffic between your VCN and the internet. When it comes to logistics, you can only have one internet gateway for one VCN. And then after creating it, you do have to add a route for the gateway in the route table to enable traffic flow, as we saw earlier. And when it comes to using internet gateway, if you take a look at this diagram here, when you're using an internet gateway, both sides can initiate connection. So that's something to just keep in mind when you're using an internet gateway. But for example, maybe you only want to initiate connection from within the VCN, but you don't want to receive anything that has been initiated from the internet to your VCN. So that would be a perfect way to use the NAT gateway. So the NAT gateway gives an entire private network access to the internet without assigning each host a public IP address. So as I mentioned earlier, hosts can initiate outbound connections to the internet and also receive responses, but they cannot receive inbound connections initiated from the internet. So one use case that is really great for a NAT gateway is when you are trying to utilize updates and patches. And when it comes to NAT gateway on a VCN, you can have more than one, but a given subnet can only route traffic to a single NAT gateway. Next up, we have communication to your on-premises network. So for this connection, you will need to utilize something called a dynamic routing gateway, and we also call it DRG for short. So the DRG will provide a path for private traffic between your VCN and destinations other than the internet, which includes your on-premises network. The DRG will essentially act as a virtual router and provides a path for traffic between your on-premises networks and also your VCNs, which we'll talk about in just a few slides. But those are the different ways you can use the DRG. And if you do want to use it to connect to your on-premises network, you will have to use it alongside an IPsec VPN or Fast Connect. And then your VCN and DRG will have a one-to-one relationship. So next up, we have communication to public OCI services. And we touched on this earlier on the route table slide, but this is essentially using the service gateway to get to things like object storage. So the service gateway will let resources in your VCN access public OCI services without using the internet or NAT gateway. So one great use case when it comes to using the service gateway, if you need to back up database systems to your object storage bucket, but of course, you have sensitive data and you don't want any of that to go over the internet. So keeping it private on Oracle Backbone will be key, and using the service gateway will allow you to keep it away from the internet. And last but not least, we have communication to other VCNs, and we call this peering. So there's two types of peering. You have local peering and you have remote peering. So local peering is when you want to connect two VCNs within the same region so that they can talk to each other. If you have an upgraded DRG, you can just use the upgraded DRG to set up that connection. But if you don't have the upgraded DRG, you will need to use a local peering gateway and attach it to each VCN. And then our second type is remote VCN peering. So this is when you're talking to VCNs in a different region. And so for this type of peering, you can just use your DRG and have them talk to each other. So now I will pass it to Sunil, who will take us through VCN security, what that looks like, load balancer, and some DNS as well.
Thank you, Winnie. Moving on into VCN security. We've talked about virtual cloud networks and we've talked about subnets. And so now we're going to go about different ways to secure them. The first of which is a security list. The security list is going to be a common set of firewall rules associated with a subnet applied to all instances launched inside the subnet. If you've been to any of the other sessions for Day 1 and beyond, we've talked about how you use policies to deny access to your resources, or to more specifically allow access because access to resources is denied by default. The same principle applies for networking. When you create a resource in a subnet, it is going to be blocked off to everything by default. So when you make a security list, you are only creating allow rules. And a security list is going to give a allow rule to all instances currently in the subnet and all instances spun up in the future. So giving an allow permission in a security list is very powerful. Another thing worth noting is security lists apply to a given instance, whether it's talking with instances inside the VCN or outside of the VCN. Here we have two example rules. We have a stateful ingress rule coming in at 000/0 for TCP on port 80. And the second is an egress rule with a destination CIDR of 10.0.2.0/24 on port 1521. Something worth noting is earlier we talked about the NAT gateway and how the NAT gateway blocks inbound connections from the resources on the internet to a resource in the private subnet. And the way that's going to work is if you're using a stateful connection, once this resource in this private subnet initiates a connection with a resource on the internet, the resource on the internet will maintain the private IP address of this resource and will then be able to initiate communications back after the first one was initiated by the resource in the private subnet. On the other hand, if that's not something you would like, you can use a stateless rule and it will obscure the private IP address so that this NAT gateway remains a one-way mirror even after this resource initiates a connection. So depending on your use case, you could have a different need for stateful versus stateless rules. Now, we also have something called a network security group, which is going to consist of networking rules that apply to a VNX of your choice, which is a virtual network interface card. So a network security group could be applied to any resource that has a virtual network interface card. And a question for you, Winnie. What are some of the differences between network security groups and security list rules?
Great question. So when it comes to what each type of rule needs from you, it will remain the same. So whatever you see here on the screen, that little screenshot, they will both require the same type of information from you, but they're going to be applied differently. So I'll let you cover that.
Yep. Good answer. So network security groups and security lists have the same rules. The difference between them is the scope of those rules. So rules like these two could be in a security list or a network security group. Here we have an example of security lists and network security groups. So we see here on the left that this security list is attached to the subnet, and it's going to have rules for these two boxes and any other instances that are spun up in the future. On the other hand, you can think of a network security group almost like a stamp. So we've taken this network security group and given these rules this stamp of approval to this instance and this instance. And the key difference between a network security group and a security list from a security standpoint is that the network security group is having a human sign off on giving out that permission to the instance. A security list is autonomously scalable and it scales infinitely. But that does mean that all resources that are being created need to have the same type of permission boundaries for them. So an example of a security list rule that might be applicable to all instances could be maybe you're connecting to an on-prem environment, and that is a resource that is a destination that you would want for all of your resources. But on the other hand, there might be other rules that are a little bit more specific that you would want to create a network security group for. So you can make sure that access is only given to the correct instances. So when going through your networking, it's really important to think about the applications of the rules in your security lists and network security groups so that you can accurately choose where to put different types of rules. Next, we're going to talk about load balancing. The load balancer is a tool that is going to sit between the client side and your backend set to help balance traffic. And how it is going to do so is through three main steps. The first step is it's going to do service discovery. Service discovery is where the load balancer is going to figure out what backends are available for it to communicate with. Second of all, it's going to perform a health check. After it knows what the available backends are, it's going to need to figure out which are healthy enough to accept requests. After the health check has been performed, which the load balancer is going to perform health checks very, very frequently, every handful of seconds, to make sure that it's accurately sending communications to only backend sets that are online. So once it's figured out what can be talked to and what is healthy enough to accept requests, it's going to use an algorithm, which is going to be set by me, or if one of you are provisioning a load balancer, whoever is the one who is responsible for provisioning it, to determine what kind of algorithm you're going to use to balance your traffic. And this algorithm can be changed after provisioning if you decide you want something new. Some examples of algorithms could be least connections, where it'll choose whichever backend has the least number of connections, send it there. Or you could use a weighted scale, so weighted round robin, and that's going to look at a certain metric, for example, CPU utilization, to determine which backend set should get the next connection. Some of the load balancer benefits are going to be fault tolerance and high availability. So by using these load balancing algorithms and the health check, the load balancer is hopefully going to be able to route around a bad or overloaded backend. And when you provision a load balancer, if you're in a multiple availability domain region, by default, it's going to provision a secondary load balancer, which it can fail over to. If you are only using a single AD or you're in a single AD region, then it will provision this backup load balancer in a separate fault domain instead. For scale, the load balancer, because it's going to evenly distribute your traffic, is going to maximize your throughput, minimize your response time, and give you avoidance towards overloading any single resource. And then finally, for naming abstraction, name resolution can be delegated to the load balancing, and your backends don't necessarily need a public IP address. If you do want them to have a public IP address, it can balance on that level. Or if you want the load balancer to sit on a public IP address and balance between backend sets on private IP addresses, that's fine. And another question for you, Winnie. What are the different options for IP address to basically live on? What are the different ways you can have IP addresses for your load balancer?
So for load balancer, you'll have two options. You can either use a reserved IP address or utilize a ephemeral IP address.
Right. And so with a reserved IP address, your load balancer will have the same IP address every single time. Whereas if you're using an ephemeral IP address, the load balancer will occupy one of the remaining IP addresses within your CIDR each time that it needs to be used. So we have a question in chat, which says that you can create security groups and traffic from internet can reach devices behind NAT gateway. When you create a NAT gateway, you will have to create rules for resources in a private subnet to be able to leave the VCN and communicate to the internet through a NAT gateway. When you are creating these type of rules, you can create two different type of rules. The first one is a stateful rule. The second one is a stateless rule. If you create a stateful rule, then wherever that destination you created that stateful rule for, from the private subnet through the NAT gateway to the internet, that resource that you communicated with will then be able to communicate back with the original resource in the private subnet through the NAT gateway. If you don't want that, then when you're creating those rules to go through the NAT gateway, you want to create a stateless rule. So the network security group or the security list don't inherently give resources any permissions. However, if you write a stateful rule and then communicate with that resource, then you are giving that permission to that destination. I hope that answers the question. So here we have a diagram on the load balancer architecture. This is just to give a brief little explanation of the high availability that is provisioned by default and is built into the cost of a single load balancer on OCI. So here we have the original load balancer that has been spun up, and we'll assume that our VCN is spanning 2 availability domains. If your VCN can only span 1 availability domain, then this would be fault domain 1 and fault domain 2 instead of availability domain 1 and availability domain 2. So we have connections coming in from the internet. The listener knows that this load balancer is active. It's going to pass the connection here. For example, for simplicity, we're going to use least connections. Currently, backends have 0, 0, 0, and 0 connections. So we're going to get the first connection. It's going to go here. This backend has 1 connection. Second connection, it's going to go here. This backend has 1 connection. Third connection here, 1. Fourth connection here, and so forth. As we get more connections, it'll go 2, 2, 2, 2, 3, 3, 3, 3, and so on. But unfortunately, there's going to be a big storm and there's going to be a power outage, and availability domain 1 is going to fail. So now the listener is going to hear that load balancer 1 is no longer active. It's going to automatically fail over to the load balancer in availability domain 2. And this load balancer is performing health checks every couple of seconds. So it's going to immediately know that these 2 backend servers are down, and it is going to balance remaining connections across these 2 backend servers in availability domain 2. For DNS, got a highly scalable global Anycast domain name system network that is going to assure high site availability and low latency, usually less than 20 milliseconds of latency. So it's very quick, and it's going to offer a complete set of functions for zone management. You're going to have public and private DNS, support for secondary DNS, the ability to import and upload your zone files. It's going to have support with all of the APIs and SDKs. And there are tools on OCI to help you create and manage these zones and records. For some of the traffic management steering policies, we talked a little bit about load balancers. You can have least endpoints, or you can have some different ratio assignment that you're going to weight based off of. Failover, we looked at in the load balancer architecture. For geolocation steering is going to be a traffic steering policy that is going to route traffic based on the source of the query. So this is going to take your responses based on the physical location of the originating request. And some situations where this would be useful is, let's say you've got a shop, an online shop, and you want to give the shop's layout to be in the language of the originating request. So if you've got a request from France, then the website would come up in French. Or let's say you've got a request from Spain, then the request will be routed to the site in Spanish, etc. Or maybe you have some sort of regulatory rules. You're a gardening shop, and maybe certain fertilizers are allowed in one country and not allowed in another. And so you want to have your shop reflect that based on the location of the originating request. Lastly, we have ASN and IP prefix, which are going to dynamically route traffic based on the respective originating ASN or IP prefix. Next, we have connectivity options, first of which is the public internet. As talked about with the load balancers, you're going to have reserved IP addresses, which is a dedicated IP address for a resource, or ephemeral IP addresses, which is an IP address that's arbitrarily taken from the unused IP address in your subnet mask, in your CIDR mask. Third bullet point is internet data out pricing with the first 10 terabytes free. Many cloud services charge for egress. Oracle charges for internet data out, which is egress that is leaving the cloud region. So if you have egress between, let's say, maybe you've acquired a new tenancy, or you have different VCNs for different teams within a single region, and you need to have egress between two VMs to talk to each other in one region, then that is not going to count towards that 10 terabytes for internet data out. If you need to communicate with a resource in a different region, or you need to communicate with your on-prem environment, then that's going to count towards your internet data out pricing after 10 terabytes, which will then start to be metered per gigabyte. Next, we have VPN Connect. This is going to have IPsec authentication and encryption, and there's two ways to deploy this. The first of which is a OCI managed VPN service, which is free, or a software VPN, which is going to be running on OCI compute. The VPN service is still free, but there will be metering on the compute service. Lastly, we have Fast Connect. Fast Connect is a private dedicated connection which will deliver a consistent network experience. It has port speeds of 1 Gbps, 10 Gbps, and recently added 100 Gbps. So we see a question, 10 terabytes internet data out per what month? Yes, that is per month. Good question. And then lastly, with Fast Connect, this is going to be a monthly subscription that is SLA based to guarantee your connection speeds. And also with Fast Connect, since you're on a monthly subscription, you no longer have any internet data out charges. So if you do have a month where you think you're going to accrue a very large internet data out bill doing some migrations, then it might be worth looking into Fast Connect to see if a monthly Fast Connect subscription would be something reasonable to save you a couple bucks. Here we've got Fast Connect architecture. We have public and private peering. Public peering is going to advertise OCI public services or public VCN routes. In this case, we're routing towards the public service of object storage. For private peering, we are going to route through the DRG, advertising private and VCN routes.
We are in the OCI console. So for the last 15 minutes, we'll just go over a quick networking demo. We'll go over VCNs, the network visualizer, and load balancer. So to start things off, we will head to the menu button on the left-hand side here, and we'll go directly into networking. So we'll go to virtual cloud networks first, as that's where you start off your networking journey. And so again, VCNs are created in compartments. So on the left-hand side here, you'll want to make sure you're in the correct compartment, which I am. And we have two active VCNs right now, but I do want to show you how to create a VCN first. So there's two ways to get started. As you can see here, you can either click on the Create VCN button or the Start VCN Wizard button. So the difference between the two is that the VCN button here, it will only give you a VCN that will be created. So it won't have anything other than the VCN, it won't have anything else created for you. It's really just bare bones for you to set up, and then you have to go back in and add everything else. But with the VCN Wizard, so there's more factor. So in addition to your VCN, you also have other things set up. So if I click into VCN Wizard, you'll see that it gives you like a little diagram of what exactly will be included with the setup. So this VCN focuses on internet connectivity. So you'll get your VCN, but you'll also get an internet gateway, a NAT gateway, and also a service gateway that is included within the creation process. And so if you want to take a look at the site-to-site VPN to a VCN to your on-premises network, this is a different setup that you can just automatically have set up based on your selection. So that's the difference between the two. So we're actually going to just go ahead and click into the first option and start the VCN wizard. So to start off, you'll need a name for your VCN. So I'll just go ahead and give it a name called testing. And then you'll go ahead and choose the compartment that you want this VCN to live inside. And then you can go ahead and start configuring your VCN. So entering your IPv4 CIDR block configuration. And then when I talked about IPv6, this is where you can enable it during the creation process if you would like. You can set that up. You can also do this after. And then configuring your subnet. So this one is your public subnet. Again, you can configure the IPv4 CIDR block size as well as the private subnet. And then you can click next. And basically this is just a page for you to review everything that will be created before actually clicking create. So you have your VCN and you also have your subnets. And then you also have your gateways that will be created, as well as your security lists and route tables. So because you are setting this up to talk to the internet, they have some default security lists, rules, and default route tables so that you can communicate with the internet and traffic will be sent. And so that's why we have like a default security list and default route tables already. But you can take a look at them here. So this is just making sure that you can send traffic to the internet and receive traffic, as well as route tables, sending it to the internet gateway or the NAT and service gateway. So even though they're setting this up for you right now, you can always go back after you've created your VCN and edit or add any rules to your security list and route tables. So I'm not going to click create, but once you are satisfied with everything that you see, you can go ahead and just click create here. So let's take a look at an existing VCN. So we'll take a look at infra VCN. And so right off the bat, you have a couple of options at the top. You can move your resource. So this is just moving it to a different compartment. You can add tags or you can delete this VCN. You have your VCN information. So the IPv4 CIDR block, you have your OCI and your default route table as well. And if you take a look at the left-hand side here, you have your resources. So all of the networking components we talked about today basically can be found under the resources section. So you have your subnets, your CIDR blocks, your route tables, your different gateways, security lists, network security groups, and etc. You take a look at that on your own time. But right now we're in subnets. So as you can see here, we have 3 subnets, 2 private, 1 public. And before we take a look at them, I do want to show you how you can create one. So of course, give your subnet a name and also select a compartment. And then this is where we talked about how subnets can be either regional, so they can span availability domain, really great for high availability, or they can just be availability specific and just created in one AD in your region. So this is actually a newer feature, the regional subnet type. So it's going to be recommended for you. And then you can go ahead and specify your CIDR block. And then also with your subnet, you will have to choose a route table to associate with it. So based on your compartment selection, you can select whatever is in that compartment, and then you can make this a public or a private subnet, depending on what you want to use it for. And then again, select options based on your compartment selection. So for this one, it's DHCP. And then here, this is where you'll also associate security lists for the subnet, so that your VNICs within this subnet will, follow these security lists. So again, based on compartment selection, but yeah, you can associate up to 5 network security lists and add them. And then you can also enable resource logging to allow resource tracking, troubleshooting, and data insights for your subnet. And then that's it. Then you can go ahead and create your subnet. So that's how you would create your subnet. Let's take a look at our route table real quick. So we have a couple of route tables here, but I'll just go ahead and click into this private one. So as you can see here, we have 2 route rules, and they might look familiar because we also used this in our slideshow earlier. But even after you've created your VCN, you can go back and add route rules for different destinations, and you can also edit existing route rules. So again, you have a lot of control, even though you're not, managing the VCN itself. All right, so going back to the VCN, you'll also find your gateways here. So this is pretty straightforward. You just create it, and then it will be available here for you to use. If you have network security groups, you can create them here, and also security lists. So similar to your route tables, you can go back and edit your rules or create new rules. So for example, so this private security, or this security list for your private subnet, these are the ingress rules, but you can always add additional ones or edit existing ones, and same goes for your egress rules. So you can always come back and make changes. Alrighty, so now that we've kind of gone through, the VCN and everything that you can find within a VCN, I do want to show you how you can use the networking visualizer tool that kind of gives you a different perspective when it comes to your networking components. So we'll go back to networking, and then we will head into Network Command Center on the bottom here. And we'll go into Visualization and Dashboards and click Network Visualizer. So here you can visually see your networking setup that you have. All right, so again, it's going to be compartment-based at the top here. So because we're in the infrastructure compartment, we only have 2 available VCNs. So that's why we see 2. And then if you click on one of your VCNs, you can find additional information on the right-hand side that pops up. And then if you did want to view additional resource details, you could do so, and also just get to the VCN details page by clicking on the name. So one other thing is that, you can see all the different gateways attached here as well. And so instead of, clicking into the gateway page and seeing what's been attached, you can already, just see that from the home page of your network visualizer. So let's see here. Next, we'll go into our different resource maps that are offered within this tool. So we have VCN routing, and we also have VCN security. I'll go ahead and click on VCN routing. And this will basically show up as, how the traffic is being routed. So if you click, so these are all these subnets within your VCN. and you'll see that each subnet has different pathways. So the public subnet will send traffic to the internet gateway in order to reach the internet. And then you'll see that for this specific private subnet, it has destinations to the NAT gateway and service gateway. So basically, just how traffic is being routed in your VCN. And then our other map mode is security. And so as you can probably assume, it's how you've set up your security in your VCN. So we have security lists here, but if you also had network security groups, they would also be shown here as well. So for example, here, this public subnet has the public security list associated with it. And, these other ones are also being associated with different subnets. All right. So next up, I want to show you a different resource map, which is called View Subnet Inventory Map. And basically in this view, you can see which types of resources have been created in a particular subnet. So in the infra public subnet, we actually have a load balancer that's been created in this subnet, as well as 2 web servers. So that's going to show up on this end. And if you wanted to, just go ahead and see, resource summary on your resources, you would be able to see that on the right-hand side. But basically here you can, just see the actual resources provisioned in this subnet. So with that being said, I will just quickly take us to our load balancer. And just quickly show you, what exactly exists within your load balancer details. So you can update shape, move your resource to a different compartment, or terminate this load balancer. But within your load balancer information, you'll see a lot. So you'll have your shape, your min and max bandwidth for your load balancer, your IP address, if it's public, and then also the networking for this load balancer. And also the most important part, your overall health checker. So it's checking your backend set's health, and so far it's okay. But if we had a problem, it would either be critical, warning, incomplete, or pending. If you scroll down, you'll see, a bunch of metrics for your load balancer. Things like accepted connections, active connections. And then on the left-hand side here, you can find your logs, also your backend sets for this load balancer. If I click into that, we have a backend set that follows the weighted round robin traffic distribution, and we have 2 backend servers, and they are both okay. So if I click into our backend set, you can also see a health checker specifically for your backends. So we have 2 backend servers, and both of them, as depicted by the number 2, they are doing okay. You also find more metrics for your backend servers, and also your backend servers can be found on this page as well. All right, so I'll pass it to Renu now to conclude our session today.
Thank you, Vinny, Sunil, and Len. I hope everyone enjoyed this session and learned something new today. Thanks again for joining us. See you all next time. Have a great day, everyone.
Thank you, everyone.